Good afternoon, everyone, and thank you for joining the first of the Merrick & Company Biosafety and Biosecurity webinar series. My name is Kelsey Judd, and I'm the Manager of Operations for Merrick's Biosafety and Biosecurity programs. Today's webinar, Biosecurity and Threat Management, a New Paradigm for Laboratory Programs, will be presented by Dr. Ryan Burnett, Merrick's Director of Biosafety and Biosecurity Programs. Before I do introduce Ryan, I want to share a few details about how the webinar is going to work today. So to keep things moving, all attendees are going to be muted, but we do want to keep this interactive. So if you have a question, you should be able to find the question box on your GoToWebinar control panel. And you can just type your question in there and it'll be provided to us. And we'll have several opportunities throughout the webinar to address those questions. If time does get limited though, we will get the answers to you in writing and provide it to you as soon as possible. We'll also be providing a link to the recording of today's session on the Merrick website, and after we finish today, we'll provide the instructions to access it. Again, we'd like to keep the webinar interactive, so we've included a few polls. Throughout the session, we'll direct your attention to the questions and provide you the opportunity to respond by choosing from multiple choice questions. Your answers will be anonymous, and we'll be sharing the tallied responses to you after the poll closes. So just as a quick test, we're going to try a simple poll so you all get a feel for how it works. So you should be able to see the question, are you enjoying the weather in your area today? And we will be opening the poll and you'll be able to provide your answers. And once it's closed, we'll be able to show you a tallied response. So there you'll see the tallied response to the poll, and if you have any questions about how to work the poll, you can provide it in the questions section. Again, if there are any other questions or technical difficulties, please let us know through the questions feature, and we'll get back to you with an answer as soon as we can. So now to introduce today's presenter, Dr. Ryan Burnett. Ryan is the Director of Biosafety and Biosecurity Programs at Merrick in the Life Sciences Business Unit. He has consulted on biorisk management programs and biocontainment laboratories at academic, government, and industrial clients in the US and over 30 countries. He's currently the program manager supporting the multifaceted operational planning of the National Bio and Agrodefense Facility as a contractor to the US Department of Homeland Security. Ryan is the editor and contributing author of Biosecurity, Understanding, Assessing, and Preventing the Threat, available through Wiley Publishers, and is currently working on his second book, Biosecurity and Global Health, Defense, and Developing Technologies, which will be available later this year. So with that, I'll turn it over to Ryan to begin the session.
Thank you, Kelsey. Thanks, everybody, for taking the time to be here this afternoon. I know we've got folks that are spread across geographies, so in time zones. Certainly appreciate you doing this, and I hope this is worth your while. We want to make this a recurring series, and at the end of this session today, we'll do a poll, because I'd be curious to hear from the audience what topics you would be interested in hearing more about, whether it is more about more detail on today's topic or some other topics. We have a nice network of folks that we work with and subject matter experts, and we're always interested to make sure that we're bringing useful information out to you. So what I want you to know today, a couple of things. Understanding that biosecurity is unique. It is unique in terms of even what sometimes we'll refer to as traditional security, and it has global implications. The information gap is closing rapidly, and threats are evolving rapidly. So I think one of the things that we'll talk about today is what is that information gap, and how has that been kind of an intrinsic element of biosecurity to date, and how that's closing, and what the potential implications of that are. Threats and hazards come in many forms, whether they're negligent researchers, malicious insiders, even do-gooders. All of these can be equal threats to programs. And I think we want to consider those in a prioritized fashion. And then finally, as a fundamental or a foundational element of biosecurity programs, threat assessment and management should be coupled with traditional biorisk assessment methods and practices. And in my mind, from my perspective, this is what it means to develop robust biorisk management programs when you really have fully thought out biosafety, biosecurity elements working in concert. So again, we're glad you're here. I know that I have the privilege of having some of my mentors here on the line today, so I hope I do you guys justice with this. Appreciate you being here. So let's talk about, this is where, believe it or not, I tend to think of things at a very fundamental level. And so when we talk about risks versus vulnerabilities and threats, can you really identify the differences here? So before we get into some of the content, I thought I would start with a scenario. And then we'll have some poll questions because I'm interested to know from the audience your perceptions and perspectives of risks, vulnerabilities, and threats. So here's a little scenario. Assume you're a biosafety officer at an academic veterinary research institute in the American Southwest. And here's some of the following elements in that program. You've got a couple of BSL-3 suites. You're doing some animal vaccine R&D, and at the same time, you support some surveillance efforts through collection and diagnostics of indigenous rodents in the area. Animals on the premises, mice and rats. You're doing some molecular diagnostics and even some genome sequencing. You've got undergraduate, graduate, and postdocs coming in and out of the laboratory, and you've got a new faculty member who's really interested in capitalizing on some developing technologies and new tools in the lab to look at genetic alterations of some zoonotic viral genomes, studying virulence factors. So with that in mind, let's go to the first question, and we're going to open up the poll here. So I'm going to open up the next poll. Bear with me. So knowing this, with respect to the person receiving from the transport of field samples, maybe these are animals, to the lab, represents a potential point of risk, vulnerability, or threat. I'm going to launch that now. We've got about 70% have voted. I'll leave it open for another few seconds. All right, I'm going to close the poll and share the results. So with respect to the person receiving the samples, 60% of you said that was a risk, 20% said that was a vulnerability, and 20% said that was a threat. Let's go to the next poll question. We'll come back and talk about these, but I've got a few here in the series. So the next one, with respect to the molecular diagnostics and genome sequencing, the outputs of the genome sequencing are stored on a network system. Is the shared access network a risk, a vulnerability, or a threat? So I'm going to launch that poll. All right, let's close that. This was pretty one-sided. 100% of the people who voted said that was a vulnerability. All right, with respect to the personnel, undergraduate, graduate, and postdoctoral fellows, students have got 24/7 access to the lab. This level of access is A, a risk, B, vulnerability, C, or threat. I'm going to open the poll here. It is open. All right, a few more seconds. All right, I'm going to close that, share the results. A little foggier this time. 38% said this is a risk. 52% said this is a vulnerability. Only 10% said this was a threat. I believe we have one more. All right, with respect to this new faculty member who's interested in genetic alterations, let's say this is hantavirus. He creates a more infectious strain of the zoonotic virus, really spooky. Faculty member is a potential risk, vulnerability, or a threat. I'm going to launch the poll. A few more seconds. All right, closing the poll. Share the results. 29% said risk, 67% say threat, and a small percentage, 5% say vulnerability. So this is an interesting scenario, right? You've got I mean, this is not an unusual academic research program, and you know, we have developing technologies. As we go throughout this webinar today, keep this scenario in your mind. We've got other scenarios, we've got other polls that we're gonna look at. But I think what's interesting about this and what this poll does, from my perspective, is it accomplishes the goal of demonstrating that we don't all have necessarily the same definition of what's a risk and what's a vulnerability and what's a threat. And I think for you know, how we develop and implement our biosafety and our biosecurity programs, that type of clarity is necessary to really make sure that we're addressing the right issues. So let's start with the laboratory biosecurity definition. This is right out of the World Health Organization Lab Biosafety Manual. Referring to lab biosecurity as the institutional and personal security measures designed to prevent the loss, theft, misuse, diversion, or intentional release of pathogens and toxins. Pretty solid definition. Covers a lot of things. What I like about this is it helps us couch our discussion today in the context of laboratories. That's really what we're talking about. I certainly, as well as you guys, recognize that biosecurity it's a big word. It has varying definitions and implications when we start talking about agriculture or genetically modified organisms. What we're really talking about and where we're going to focus today is at the laboratory level. Compare and contrast with a little bit of quote-unquote traditional security. By no means do I mean to belittle the field of security, not at all. What I do like to point out is that you know, there are 5 major components, and this isn't my idea. This has been referenced for a good while now in terms of what makes up a good security program: physical, informational, transport, material, and personnel. So when we tend to think of security, we tend to think of it in the context of protecting an asset. Maybe that's a person, maybe that's a valuable. We often equate security with the mentality of gates, guards, and guns, and that really speaks towards access control and who you don't want to get in, again, protecting assets. And of course, the assessment of personnel, you know, who is physically or mentally or emotionally fit for duty or to have access to the assets in question. So we're going to challenge this a little bit today in the context of the bio world. So I'd like to start with this. What really makes biosecurity unique? In other words, I have a lot of people ask me, and they say, well, isn't biosecurity just a function of security? And the answer is yes and no. Let's talk about what makes this unique. The assets in this case that we're looking to protect, biological materials, they're difficult to detect. Think about that from, you know, in comparison with, you know, radioisotopes or people, you know, other assets that you can see and detect. Bio isn't always that way. Some of these biological assets can actually reproduce under the right conditions. So from a theft or a loss perspective, in terms of the consequence downstream, you might only need to remove a small amount of them. Nucleic acids, you know, there's the backbone for all the data that occurs in these organisms. Yet nucleic acids like DNA, you know, it's fundamentally benign. Can't actually do anything without the cellular machinery around it. So is that still worth protecting? We're going to talk about a couple of examples about information. Who decides what info can and should be released? Protection so far has been the knowledge necessary to work with them. So remember earlier I referred to this gap, and that information gap has been a big aspect of protecting the organisms, the biological materials, and the potential downstream consequences of having access to them. In other words, in layman's terms, you know, in the old days, you had to have a PhD to know what the heck these things were and how to work with them. And that's changing a little bit. We're starting to see biology become a field that is a little bit more open to the public and people without advanced degrees. A big point that I want to make in today's session is this is not just about select agents. Too many times have we worked with programs that have checked the select agent box, if you will. You know, maybe they're a select agent registered program. Obviously, there's some regulatory requirements in terms of those security programs and features, and that's where they stop. And I would argue that that's not the right approach. There's a lot more stuff to be protected other than what is just prescribed as part of the select agent program. So whether you're in the U.S. or not, you know, there are other things to protect. We're going to talk about those. So, not to oversimplify again or belittle anybody in the profession, because this is a huge profession with a lot of impacts. In my simplistic view, I tend to look at the Biorisk Assessment as the foundation of what we know of as biosafety. And this really starts with the fundamental knowledge of the biological agent or agents and their intrinsic properties. You know, are they aerosol transmissible? What's the infectious dose? How can they be inactivated? And so on. So it is those intrinsic properties that help us identify the potential risks that can lead to a consequence. And I think, you know, one we all think about is, you know, exposure to an infectious agent. You know, and a potential consequence of that of falling ill because of that exposure. So when we think about these risk assessments from this perspective, I think, you know, the biosafety professionals that are out there, they understand the intrinsic properties of these agents, and therefore the understanding and the mitigation of the risks is intuitive. And this is now a science and a profession, and you know, it's amazing, honestly, what has changed over the past several decades, both here in the U.S. and around the world, as we have taken this core fundamental knowledge and spread that. Let's look at the other half of that equation, though, and that's the threat assessment aspect of this. There's a whole other subset of intrinsic properties to these biological agents that don't have a whole lot to do with their biological properties. And those can include their monetary value. Could they be used to, you know, be a part of some type of weapon? There's the dual use consideration and so on. So when we do a threat assessment in the context of biosecurity, we really have to look at what is the threat source and the directionality of this. And in my little brain, I think about the biological agent itself imparts certain risks. In the biosecurity context, we really think about threats and hazards that impart themselves on the agent. So there is a directionality here. One of the things that we talk about a lot is, you know, biosafety professionals being risk assessment professionals, and I truly believe that. The question becomes, for a good comprehensive biorisk management program that includes biosecurity, do we expect those professionals to also be threat assessment professionals? And I think that's a question we have to grapple. And there it is. So what type of professional are you? The biosafety pros, they really understand these agents. They have an aptitude to minimize the risks with control measures and practices in science. So the baseline is that risk assessment process. On the security side, you really have to understand the attributes of the asset, whether that's a person or a valuable material, and design the threat management strategies to prevent access or harm. So the baseline in that field is the threat assessment. Your classic example, of course, at least the one that always pops in my head, is the Secret Service agent protecting the president. The president is the asset. Whether you actually think our current president is an asset or not, that's up to you. But regardless, that's what the Secret Service does. They protect that individual. They have to understand the intrinsic properties of that asset. their personality, their movements, their preferences. All of those things get factored into how that threat assessment is built. And I think one of our challenges and one of the things that makes biosecurity unique is how do we capitalize on the intrinsic attributes of the agents we're trying to protect in designing our threat assessment process. So we've got a biorisk assessment process. It's one that works very well. We use it all the time. Where's the biothreat assessment? I think we can learn a lot from law enforcement. That's really where threat management and threat assessment has been born. In that context, threat, I put here, tends to mean person. Let me restate this. It absolutely means person. In the security world, when you hear threat, that means a person. That may not always be the case in the biosecurity realm. So you'll hear me say threats and hazards a lot during today's session. Are there threats and hazards that can be unique to the biosecurity world? Yeah, absolutely. And can we build threat assessment tool around biological assets? I firmly believe so, and in a lot of cases, we already do. We may not just be doing it as structured in a way as we do with our biorisk assessments. So here's an opportunity for questions. You've got your question box. If you have a question, fantastic. If you think of it later, that's fine. Put it in the box. We will get to it. If we run out of time, we'll make sure that gets back. So I'm going to move on, seeing none at the moment. So unique subset of security with global implications, and I think it's important for us to understand that although we're focused in a lot of times in the laboratory level, it's a big world out there. There are a lot of implications here. Good friend of mine, Sam Dietrich, she has really developed a lot of things recently about global health security agenda. In fact, she's the manager of the global health security agenda program for the Association of Public Health Laboratories, and I stole this slide from her because I love it. You know, here's a quote from President Obama in 2011. So the global health security agenda, you know, really is a multinational focus to assess and develop you know, tactics and strategies that will help us in the basically the combat against infectious agents and pandemics, epidemics, etc., whether they are natural or whether they are man-made. So biosecurity is a pretty big component of this. In fact, of the multiple pillars that make up the global health security agenda, there's an entire pillar on laboratory biosafety and biosecurity. If you're not familiar with the GHSA, I encourage you to go look it up. CDC has a very nice site about this, and you can get some information. And a lot of countries, as you can see here on the map, have already been through some of the phase 1 evaluations, and it continues to roll along. This I snapped right off the Blue Ribbon Study Panel on Biodefense homepage. Biodefense is not biosecurity. I think that's, you know, there are a lot of bio terms out there. I'm going to throw another one at you later today. It's not biosecurity. Biodefense is really looking at, you know, our capabilities, you know, whether it's at a state, local, national, international efforts to prepare and defend ourselves against natural and intentional biological threats. But biosecurity, again, has to be a component of that. Why? Because, you know, laboratories are often at the front line of detection and mitigation. We're going to talk today about gene editing. This is some newer technology over the past couple of years. It's really making a strong way into the laboratory and the life sciences. So here's James Clapper, Director of National Intelligence, and a quote that came out of his report, where he indicates his sentiment that gene editing is a potential weapon of mass destruction because of its distribution, low cost, and the crazy pace at which this is growing. I think today that might be a bit of a stretch to consider gene editing a WMD, but I certainly understand the sentiment given the implications that the technology has. So once again, I think the impacts to and from biosecurity have far-reaching implications. Any questions on that so far? Looks like we're doing okay. Again, feel free to type them in, and we can address them later, time permitting. The information gap is changing. But we still have a way to go. So consider this kind of the op-ed piece of the webinar. Things are changing, right? Community labs, biohackers, DIY bio. I know in the biosafety community and then the law enforcement community, and as this continues to grow, I know that there's a general sense of unease in the industry. You're looking at a snapshot, a photograph here from a website called biocurious.org. Really marvelous organization. Honestly, they're doing a lot of stuff, a lot of technology, a lot of education. So we'll talk about the pros and cons of this, but I like this quote: "Biology should be accessible, affordable, and open to everyone." I think that challenges the central dogma of how biological research and education has been done in the past. There is a lot of positive momentum between the community labs and biosafety associations, and I think that's good. So there's potential for a future discipline of biosafety professionals, even, because I think these things are going to grow. And we're starting to see a greater emphasis on responsible science, and I think those are all good things. All that being said, there are some potential implications here. What are they doing in there? Gene editing is one of these things that really has made its way. And they're doing a lot of education. They've got a lot of technology that's coming into these laboratories, et cetera. So gene editing, we're going to talk a little bit about that. I'm sure there's some folks on the line today that are quite savvy and up to speed with what all this gene editing is. For those of you that are not, these are newer techniques on some old technology. We've been doing recombinant DNA work and monkeying with DNA sequences for a long time. I consider that to be one of the hallmarks of the upswing and the creation of the entire biotechnology sector. New tools: CRISPR-Cas9 allows strategic modification of genetic sequences. That's pretty powerful. That dramatically increases our ability and our reach to really specifically and discretely target genetic sequences for modification. We're already seeing through FDA approval gene therapy products that are hitting the shelves, and I think that's very exciting. Shows great promise. But again, there are always the safety and security considerations around these developing technologies. So a little more on that. So how does it actually work? This is I stole this from Kavita Berger, a friend and a colleague over at Griffin Scientific, and I think this is a really good example of how gene editing works. So you have a statement: Henry should do his homework, and you want to change should to could. Gene editing essentially works like this. You can specifically target the S and the H with new gene editing technologies like CRISPR-Cas9, and you can snip out of that entire sequence just the S and the H. And you can see here that you've got some complementary sequences, right? You want to replace it with the C to make that should become could. But you've got to give it a way to target that sequence. So the way that you do that is you've got some sequence redundancy on either end of that, and that helps it align and find the right position. And then of course the final piece of that is you insert the C. Now you've changed the sentence to Henry could do his homework. Pretty powerful stuff, getting a lot of momentum. I am going to show you a brief video here, if this will work. I just have to remember how to do it now. Bear with me. All right, I hope that came through for everybody. Powerful technology. Interesting to see how this is going to develop, but it's already got a lot of implications. Let's talk for a minute about gene editing, great possibility, great risk. And I think there's a classic example here, 2011, 2012. Some genetic modification technology was used to augment H5N1 avian influenza, really trying to study the transmission and the infection components of the virus. So why would you even do this? Why would you look to augment these potentially, dangerous attributes of the strain? Well, it helps. It's information. We can actually look at, as flus, as viruses mutate over time. I mean, we can actually help predict those and build better vaccines. So this is all done in the absolute best of intentions in science. Two separate publications came out, right about the same time, and then everything basically went crazy. And the reason why is because just like every other scientific peer-reviewed article, you've got to publish the detailed materials and methods for validation by other peers in the field. Obviously, this is like a recipe for how to do this. So this really goes back to the earlier question I posed, and that is, who decides what information should be made available when we talk about these technologies, when we talk about potentially dangerous biological agents? It's a good question. And then we think about, well, who should have access to this? Now, back up just a minute to when I was talking about community laboratories and making biology open and accessible to everybody. And you think, well, how bad could that be? How small is the information gap actually closing? And do we have real issues here with this? Forget your major, terrorist groups looking to overthrow modern civilization. Let's just bring it back home. I've got another video I think will help tell you a little bit about where these things are going. This was rather unbelievable. There you have it. A biohacker injecting himself with untested herpes gene therapy. Is he the next Salk or Pasteur? Who knows? Anyway, I think the point of this is I want people to understand that the information gap is closing. We are there greater access to tools and techniques and technologies. Those are out there. You don't have to be working in a federally funded academic research laboratory to have access to some of these things. And I think that really can scare some people. So we have a question that just came in. It says, why are these DIYs not controlled by regulators? Great question. You know, there are a lot of debate over that, and I think that from a regulatory perspective, you know, folks are scrambling to figure out the best way to regulate some of these things. Now, I will tell you that they are not immune to existing regulatory structures, such as the Select Agent Program. So it doesn't matter whether you're DIY or at home or in a community lab where everybody pays monthly dues to have access. You know, if you're working with regulated material, then you will be regulated. So I think, you know, the broader question here is what does our community in terms of biosafety and biosecurity, what do we have to offer? I don't think we're going to slow the march. Science always moves faster than the regulators. I don't think we're going to slow the march of these laboratories and biohackers and DIYs. I think the question is, how can we help those communities continue to evolve responsible research conduct, good safety and security techniques? So that'll be a question over the next many years, I'm sure. It's not going away. Right now, gene editing in 2015, that was a $400 million market. By the time we get to 2021, it's forecasted to be about a $2 to $6 billion market. So you think about from a market standpoint, you know, is this going to go away? Is this a fad? Is this the next .coms? You know, nobody can say for sure. My sense is that these things are not going to go away, and they're going to keep growing. And they're going to grow much faster than the regulators, and they're going to grow much faster than we can turn out safety and security professionals. So I think we have to look at alternative models of how we can actually add value to this market, so that we don't end up with either you know, some horrible consequence as a result of negligence or you know, ill intent. So here's kind of the bottom line. These community laboratories, biohackers, DIY, provide opportunities, good and bad, right? Entrepreneurship, novel projects, under-addressed issues in biology. I know faculty members at universities that attend some of these laboratories to do side projects. So it's not that everybody in these organizations is completely uneducated. But at the same time, you know, we're providing, or these laboratories are providing, a lot of open access to training and tools, particularly around, you know, gene editing, gene modification, and the implications of that, I think, are pretty far-reaching. Progress, yeah, the FBI has done a very good job of engaging these communities, and so is ABSA. You know, you can go to the ABSA website and read about that relationship and what's transpiring. Through my dialogue with some of the community laboratories, I'm also finding that it's going both ways. They recognize a lot of the needs, and they're interested to establish some mechanisms by which they can really put people in these areas with good, solid biosafety and biosecurity expertise. So let's think about the risk assessment gaps. When we do these risk assessments on these things, you know, here's where some of the gaps are. A detailed understanding about the functions of the specific sequences that are being edited. Right now, very limited, and that's frequently, you know, you cannot reproduce a lot of these things. The effects of the specific changes in different genetic backgrounds is not well known. There are websites now where you can plug in sequences, and you can tweak sequences, and you can see what the potential outcome is. Very, very basic level, though. Obviously, designing and conducting the experiments, there's a lot of uncertainty, new field, limited info, and of course, you're dealing with human variability. we have really no sense of any of the ecological consequences of these modifications. And when you think about the utility and the feasibility of success in particular, really depends on the organism that's being edited and the gene delivery approaches, et cetera. So these are some of the things that make doing a risk assessment in these environments with these technologies rather difficult. And I think a lot of these things can apply to not just the safety elements, but also the security elements. Here's a new word. I saw some good banter this week about this word. I love it. Cyber biosecurity. Yeah, I think people always are going to put that little bio in there and create new terms. At the same time, this one's got a little bit, it's got some teeth. A couple of recent publications with folks from Colorado State and Virginia Tech and others really talk about the convergence of biology and cybersecurity with respect that because of new technologies, because so much of what we do in biology is information-based, that there is a need to really look at the cybersecurity elements from a bio perspective. And I think this is a potentially an emerging field, still has a ways to go. But the focus is really looking at the bioeconomy. There's really a lot of stuff happening in biopharmaceutical, biotech, agriculture that is being more and more information driven. And I think that's where some of these considerations are coming from. So what are the cybersecurity vulnerabilities at the lab level? Well, at the lab level, obviously some of these aren't new, but some of them are when we think about access or theft to intellectual property. Remember when I said that biosecurity doesn't just begin and end with select agents. There's a lot of other valuable information and assets out there that require security. Corruption of data, unwanted monitoring or hacking of communications about the procedures or the agents, access to manipulation of the cyber-physical interfaces, networked or remotely accessed instrumentation, procurement actions. Is there possible interruptions to or concern with respect to supply chain? Of course, overall facility access security systems, and then there's a host of others. So this is an interesting field. We'll see how this one develops, and I think we'll just see how this one rolls along. But it's interesting to watch this. Notably, and Merrick was part of this, last October, Virginia Tech up in the DC area put on a cyber biosecurity workshop. And I think for the collection of folks that came to the table, including academic, federal agencies, including the FBI, some nonprofits and private companies, a lot came out of this actually. And I think when we try to think about, are we really codifying or defining a new industry and a new thing that needs to be, first of all, bear the bio term and then receive resources and expertise, made a lot of good first steps. So I would encourage you to, follow what's going on with institutions like Virginia Tech and CSU as they continue to look at this interface between cybersecurity and bio. Gene synthesis is another one. So we talk about editing, we're editing sequences, but at the same time, there's the ability to synthesize gene sequences as well for a variety of uses. Sequencing used to be an incredibly laborious, expensive task, not so much. Now there are a variety of companies that have very efficient and low-cost gene synthesis technology and capabilities, and there are people that capitalize on this. Here's what's interesting, and I give props to a friend of mine, Nick Dunaway, who first developed this figure. But when we think about how gene synthesis can work here, so let's take H5N1 for example, and you have basically contract research organizations that can produce individual H5N1 genes based on essentially email orders. And then maybe you've got a reseller. So here's what's interesting is if you want to stay below the radar, you don't have to order the entire H5N1 genome from one place. You can break it up. You can hit a variety of different companies and pull that information together. You, as the potential quote unquote bad actor, receive all those pieces. You can stitch them back together in your own laboratory. Lo and behold, you've got an intact H5N1 genome that's ready to be inserted into a capsid. So the interesting thing about this scenario is that based on our current laws, no U.S. select agent regulation violation has occurred in this scenario. And I think that's a little bit concerning when we think about it from a security perspective. So this is currently happening. And when we think about, maybe not with H5N1, but this is all out there now. So I think we once again, when we think about the information, when we think about the results, and we've got a scenario for poll questions coming up, and we're going to tackle this issue in a little bit more detail. So here's kind of what it boils down to with advancing technology and biosecurity. Really, there's limited policy or technology currently supporting these gaps. For example, to my knowledge, and I think this is something that's being worked on, but to my knowledge, there is no database platform that allows a privately held gene synthesis company to screen every single order that comes in to understand what it belongs to. You know, is it a regulated agent when synthesized and cloned and expressed, et cetera? That doesn't exist. The synthetic bio community, generally, they're in favor of rules, and I think they approach this from a standpoint of reputational risk. They want to do business. They want to make money. They want to do things responsibly. They don't need the bad press. So they're in favor of more rules and regulations. Same time, the bad actors who may have access to some of the open biology education environments, they don't really care about the rules. They never will. So the vulnerability identification and mitigation can actually reveal gaps. And I refer to this as the dual use conundrum. Yes, I trademarked that, because I liked it. I like the term "duddux" so much. That's a joke. So really, what I mean by that is sometimes when we are assessing vulnerabilities, we reveal things that maybe we don't want to bring to the surface. In other words, sometimes it can be best to leave a vulnerability, hidden. That actually happened with Sony CDs years ago, when they had put some spyware or malware on their music CDs, that when they got popped into computers, it installed this. That actually was found by a person. The person didn't bring that vulnerability to public knowledge because of their fear of being prosecuted against certain laws with respect to information. So there can actually be backfiring there. So that's why we talk about smart corrective action. In the context of biosecurity, we're not writing code and pushing buttons like we do perhaps with cybersecurity vulnerabilities. It actually takes time. So there's time to patch vulnerabilities in our biological research environments, production, agriculture. These things are harder to patch. It's not a quick fix. So I think we as a community have to think about, what are the best ways to identify the vulnerabilities without necessarily exposing them to bad actors. That's a tough order. Think about the H5N1 papers I referenced earlier in terms of putting out public information. But at the same time, we do have the ability to introduce regulatory anchor points, not just at the agent level. What is the agent you're working with? But arguably, the more important piece of this is, what are you doing with it? What's the experiment? What are the risks and the threats that are associated with the manipulation and the experiments, not just the agent itself? So I take you back to this diagram before we move to the next section to show, again, in my little brain, kind of a systematic, concerted way of how I think about the interplay between biorisk and biothreat, taking into consideration both the biological and the non-biological intrinsic properties and the directionality of threats to the agent and downstream to risks and resulting consequences. So I termed this webinar "Changing the Paradigm." And the reason I termed it that is for this very reason. I personally like this definition out of WHO in terms of what laboratory biosecurity means. But look at everything we're throwing against it now. DIY bio, gene editing, gene synthesis, potentially cyber biosecurity. Does this definition and our current framework and understanding of biosecurity really enable us to mitigate the threats and the potential downstream resulting risks as a result of these new areas. So I think this is where our paradigm has to perhaps be changed and expanded a little bit. So let me see here. All right. Let's move to our poll. This goes back to our earlier example. Let's say you're a partner in a relatively new but profitable gene synthesis company in Boston. You've got a new client from Russia, and they're sending you orders for synthesis of several nucleotide sequences, including a significant portion of an open reading frame of good old tularemia virulence factors. So, F. tularensis is a U.S. regulated select agent. This group in Russia is ordering DNA sequence that encodes a potential virulence factor. Do you need to report this client order to any federal authorities? I'm going to find that poll question and open the poll. Here we go. Leave it open for a few more seconds. All right, I'm going to close it, share the results. 70% of you say yes, this does need to be reported or is required to be reported to federal authorities. 22% of you said not sure, 9% of you said no. The last time I checked, believe it or not, I'm not saying you shouldn't report this to federal authorities. To my knowledge, there's no regulatory requirement to report this. If somebody on the line knows differently, I would love to find a reference to that. But my discussions with folks in regulatory seats indicate that this is not a reportable event just because somebody orders a DNA sequence. All right, let's change it up a little bit. Let's say that you receive word from a friend who happens to be at a competitor gene synthesis CRO right down the road that the same group has ordered similar sequences from their shop. So it looks like whoever this group is, they're spreading their order out, right? Does this need, because of this now do you need to report that? So I'm going to launch that poll. All right, couple more seconds. All right, I'm going to close it up. It's getting foggier now. 43% say yes, 17% say no, 39% say not sure. Again, my current understanding of this is the answer is no, you do not have to. So, you know, there is, I think there's some good comments coming in about this, and one of them is, you know, required or should report are different. You know, that's an ethical question. Totally agree. So I think should report, that's up to you. That's up to you as a partner in this company that, you know, you're new, you're profitable. And then of course you also have to think about potential export control laws as well. So good comments. All right, now here's an interesting one. One of your techs brings you, you know, the completed order and shows you that several of the sequences they're requesting from this factor have altered sequence that may confer increased virulence, right? A stronger bug. Do you have to report this? Let's go to the polls. Couple more seconds. All right, going to close the poll, share the results. 67% say yes. So the distinction here now is, when you look at our current regulations in terms of augmenting, or altering changes to, a regulated agent or even an unregulated agent that confers stronger capabilities of that virus to cause harm. What does that look like? 67% of you say yes, this should be reported. 25% still not sure. I appreciate the honesty, by the way, in these polls in terms of the, hey, I don't know. I think that's very good. So here's the ethical question. After all of this, you're a partner in that institution that's making money on this. You've got a reputation to protect. You have no idea what this group is going to be doing with those sequences. Do you fulfill that order? And I think my poll actually says Chinese instead of Russia. My apologies. I'll launch the poll. I don't know how many of you just absolutely say, this is awful, I'm getting out of this business. All right, I'm going to close it up. 4% of you quit. I totally sympathize. I understand. 13% said yes. 83% say no. So overwhelmingly, the group feels that the answer to this question is no, you would not fulfill that order. Of course, this is an ethical question, and it's an interesting question. Assuming all legal issues are in the clear in this type of scenario, you have to think about what does it mean from a reputational risk perspective, and that's a very important factor here. So it's a good question from a dual use perspective. Sorry, I didn't share that last poll. So 83% say no. These are the types of issues that I think we're going to be. In fact, I know that some institutions are already dealing with. So a lot of questions. I'm going to send out some materials that relate to this scenario afterwards, so the attendees will receive some information that I have pulled some of these scenarios from, so that you can read about it and make some decisions of your own about some of these scenarios. The important thing that I want to point out is that there's still ambiguity in the answers, and there are still some pretty significant security concerns about this. So, we're coming to the end of this. We've given out some scenarios. We've talked about a variety of issues and developing technologies. Let's spend a few minutes and really talk about threat assessment and management as a foundation to biosecurity. So threats and hazards, what are they? What do they have? They have direction. And this is a way that, the threat management folks that I've worked with over the years, these are some of the things that I've gleaned from them. And one of the things we have to think about when we think about threats is, there can absolutely be a threat out there, but if it's not moving toward your asset, is it really a threat? Does it change your priorities? I think the answer probably is yes, but that's the kind of stuff that have to be dealt with. What else do they have? Proximity. How close is the threat to your asset? Is it close? Is it far? How does that change how you think about it? How quickly is it moving? Is it quickly or slowly moving to or from your asset? Frequency. Is this a recurring or a one-time threat? Severity. If the threat is encountered, by your asset, how damaging is it going to be? There has to be a need for a vulnerability. In other words, is there a runway for the threat to land on? I'm going to talk about that a little bit more in a minute. Stealth. How detectable is the threat? So it's interesting when you think about the diagram I showed earlier of kind of the bio-threat assessment process and the biorisk assessment process. And when you put those things in there, when we have to identify threats and vulnerabilities and the resulting risks, what do we know about those threats? This is a greatly oversimplified formula, but I want to talk about this for a minute. A threat plus a vulnerability equals a resulting risk. I know my associates that may be listening understand my like of comic books. Big surprise, a biochemist who likes comic books, I know. And I think about Superman a lot, probably more than I should at my age. But think about this from a vulnerability standpoint. When we think about, a threat can be a bullet, right? But Superman doesn't get hit, they can't penetrate him, they can't hurt him. So there's no vulnerability, ergo, there's no resulting risk. Throw kryptonite into the mix, things are a little bit different. That's a vulnerability, right? That imposes a vulnerability. So the kryptonite is actually the threat. So we have to think about that. And there are absolutely challenges to this simple equation I've put up here, but I think it helps get people in the mindset that we really have to look at threats and vulnerabilities in tandem before we can really assess what the resulting risks are. So let's do a poll. Severe storm watch has been issued for the area surrounding your lab, which includes a BSL-3 space. And you're concerned about the age of the backup generator during a power failure to maintain negative inward airflow. So the poll question, the aging generator is what? A risk, a vulnerability, or a threat? Poll is open. A few more seconds. All right, I'm shutting her down. Let's share the results. Most of you said it's a vulnerability. That's where my brain goes. When I see this, when I think about the directionality of threat. So when we talk about directionality, when we talk about severity, when we talk about all of those things that I showed on the previous slide, where does everything fit in that little equation I showed of threat plus vulnerability equals resulting risk? My mind says that an aging generator in this case is a vulnerability in the entire system. Moving on, the approaching storm. What is that? Is that a risk? Is that a threat or hazard? Sorry, threat assessment guys. Is it a hazard or a vulnerability or risk? Let me open up the poll here. This is pretty one-sided. I'm going to go ahead and close the poll and share. 100% say this is a threat. Absolutely agree. It's got directionality. It has the ability to confer a consequence. In this case, we're looking at it from a backup generator and maintaining airflow. So that absolutely is a threat. You guys are getting good at this. Finally, the possibility of a power failure. What is that? Is that a risk, a vulnerability, or a threat? Poll is open. All right, a few more seconds. Going to close it now. There are the results. Just about 80% of you say the possibility of a power failure is a risk. So this is a very simple example from a very simple equation. But I think when we take this type of planning and expertise and we actually try to apply this to our laboratory, it's important for us to silo things appropriately so that we can identify and mitigate appropriately as well. So I tend to also, again, based on the model I proposed earlier, that this power failure is the resulting risk of a threat or hazard, in this case a storm, interfacing with an aging generator, which is a potential vulnerability, and the resulting risk is that there's a power failure. So it is, let's keep moving. Hide that. Now, I will say that all of these can be challenged, right? Because of the directionality of threats and risks, you can walk around and look at this scenario from the other side and you can say, okay, no, I actually think the storm is a risk, or I think the possibility of power failure is a threat. And it just depends on where in that spectrum you're sitting. Are you looking at this from the asset of a biological agent? Are you looking at this from the perspective of a person in public who's walking down the hallway outside of the lab who's about to lose power and potential directional airflow? So your viewpoint has a big impact on how you decide what is a risk, what is a threat, and that's an important consideration. I don't think this is anything new for everybody, but I like to show this in terms of how we do a lot of these assessments. Probably a lot of folks have been through more than one, if not a bazillion, of these assessments in their careers. We tend to look at identifying risks and threats based on their frequency and severity. And this is, again, an oversimplified permutation of some pretty standard risk and threat assessment type platforms, but I think it works pretty well for our example. For example, a frequent scenario might be something that occurs, at least one occurrence each year. Now, depending on what you're talking about, that could be eons. Your frequency, depending on the element that you're curious about, could be more like a day, right? Not a year. So the scale of this is up to you to really decide as an implementer. The severity, when you think about, are your assets going to be compromised? What does that severity look like? Catastrophic all the way to negligible. Again, the definitions in the box, those are subjective. Those really need to be tweaked to your particular program, but it gives you a guideline of how to think about these things. Probably everybody has seen some of the resulting risk classification matrix here in terms of, what is intolerable all the way down to what is tolerable. And again, this is all subjective. You have to make these decisions for your institution and your programs and your research or your products. But this is one way to do that. So here's a very brief example, and we're not going to go through this in detail, but I want to point out a couple of things. You'll notice here in the threat hazard column that 1, 2, and 3, the threat/hazard is all the same. It's a negligent employee who's got access. Possible cause, though, there could be multiple causes, which means that there could be multiple vulnerabilities. So a threat can have more than one vulnerability to capitalize on, and I think that's important. What this does is it all boils down into what I consider to be the potential consequences or the resulting risk. So in our little story here, with this negligent employee who has access, we really don't want him to get access because he's negligent. And that could result in a lot of things. Maybe he gets access to information or material that we don't want. A breach in containment because he doesn't know how the hell to open doors, and close doors, and take his PPE off properly, what have you. All of those things can come down to that. The point that I really wanted to make here is that there can be multiple vulnerabilities per threat or hazard. You can see over here on the unmitigated side, how frequent do we think that is? What do we think the severity of that is? And therefore, based on the table I showed previously, what is that risk classification? If we go through the mitigation of that, however, so if we scroll to the right on this spreadsheet, we can see that for each one of those vulnerabilities, we can patch that with safeguards. And when we go through that exercise, what we hope the outcome of that is we're going to either decrease the frequency or the severity, and therefore the risk class of this potential threat, vulnerability, resulting risk combo. Other attributes that usually fall into this: what is the action or the recommendation? Who owns this? I think everybody probably has a pretty good sense of what it takes to go through this. It's interesting to me that, in the years of working with folks on this, that the format, the process for doing these assessments, pretty well understood. Most people don't have a hard time with that. Where people really get hung up is identifying what's a threat versus what's a risk versus what's a vulnerability, and where on that directional spectrum are they sitting, that they can make the right question, the right assertion. So if you haven't caught on to my point here so far, is that really biosecurity is a form of threat management. We're talking about implementation of control measures to minimize and mitigate and manage threats and hazards. Biosecurity, this is a condensed version of the WHO implementation of control measures necessary to minimize threats and safeguard biological agents and valuable biological materials. They don't have to be dangerous to be valuable. That's what the VBM is. All right, we've got 15 minutes, which I think is just enough time to wrap this up. Feel free to keep logging your questions. I am trying to move along, but we will respond to questions and requests. So one of the biggest challenges I think that programs have, or at least what I have witnessed working with programs, is how do you integrate this? I think that collectively the biosafety profession, with the support of international agencies and even domestic here in the US, done a great job of taking the fundamentals of biosafety and implementing that in areas around the world, right? And I'm not just talking about developed regions such as Europe or the US, Canada, what have you, but even beyond. I think that I've been fortunate to work in a lot of countries, and there's a real pride about learning and implementing biosafety. People latch on to that. They want to build it. And I generally, my sense is we've done a very good job, and we've made some really good strides in the whole spectrum of this. Biosecurity is a little bit different, right? I think that a lot of us are aware of some of the challenges in terms of defining it, the resource limitations, the expertise. There are a lot of things that go into this. And yet there are a lot of really good programs that are coming out of the US and some European countries and Australia and others that are looking to build more biosecurity awareness, knowledge, and capacity around the world. And I think that's important. I think it's equally important that we understand what we're talking about. So I like to think that the path forward for really building good biosecurity programs as a component of overall biorisk management programs, we really talk about accountability and integration. And we started with the SIN workshop agreement in terms of a biorisk management system, and now we're moving towards an ISO standard, and I think that's pretty exciting. Performance-based, performance standard, but I think that's really good. We still have our two tried and trusted tools here, and that's the WHO Laboratory Biosafety Manual, as well as the BMBL joint publication out of CDC and NIH, which we'll soon be seeing another version of that, I think, with even a more robust section on biosecurity, and looking forward to that. So these are just a few of some of the tools that we have access to today. How do we integrate those? Well, I think the developing ISO standard will really help institutions in terms of codifying what their biosecurity program looks like. We have a lot to cover, though, right? So is one ISO standard really going to help us with the total spectrum of biological risk and the areas of responsible science? Again, a slide developed by Kavita. I really like it because it really shows that spectrum. Everything from misuse all the way up to some of the ethical considerations in terms of fraud and plagiarism. There are a lot of things that factor into what may have an impact on your program or your production. Biosecurity equals threat management, right? When you're building biosecurity, you're building threat management. That's what the TM. I think this really comes from a good use of a threat assessment and a vulnerability analysis, the TA and the VA, integrated along with your risk assessment, the RA. All those things have to be brought together. I wouldn't do one in a silo. In fact, what we push is we sit down and we look at them in a comprehensive way. What does your biosecurity program look like? I think there are a lot of similarities between what we see with other laboratory management systems, including biosafety, and that's your administrative controls, training and drills on a recurring basis, personnel suitability and reliability. That's always a touchy subject, but it's got to be dealt with. Material control and accountability, as well as the management and implementation. So when you think about what goes into building this type of program, what does that look like? What are the components? I think these are some of the fundamentals. We haven't talked about it a lot. I'd be happy to do another session on this, but threat management also includes response and recovery. We've talked about prevention and mitigation and minimizing. Well, guess what? Stuff happens. I think we all know that. So despite your best efforts, vulnerabilities and threats are going to collide, and you will have resulting risks. So your plans do need to include response and recovery. What do you do when you're responding to a threat? How do you recover from the resulting risk that may occur? Some of the initial steps to implement when you're thinking about either reviewing your existing biosecurity program or really building one from the ground up, take a look at your documents and your systems. You need to be able to identify gaps, or as we've been calling them, vulnerabilities, right? Some vulnerabilities could exist even at the paper level in terms of what are your policies and procedures. Develop the training materials. This is pretty critical. Those should be based on the administrative controls, the policies, the procedures that you're creating in alignment with the program, the research, the production, etc. You've got to develop the trainers, right? I think that a lot of us feel very comfortable in the risk assessment world. We may not be so comfortable in the threat assessment world. I think about toward integration. Again, this is very oversimplified, but there's a lot of crossover between all these things. But when I think about just a very simple diagram, the risk assessment really provides that foundation to your biosafety program. Threat and vulnerabilities, those assessments and analyses really feed your biosecurity programs. And I think when those things come together, assuming that biosecurity also talks about personnel reliability or biosurety, as we call it, that the result of those is a good comprehensive biorisk management program. What does that look like in terms of laboratory management systems? Because there's a lot of other pieces, right? We know that laboratory management is really built on a lot of things, not just the biorisk management, but there's environmental health and safety, occupational health, regulatory compliance. We've got to be having discussions with our institutional security. And of course, emergency response. We talked about response and recovery. So all of those things come together into what I think of as good overall laboratory management programs and systems. So we've really been talking about kind of some front-end stuff that leads into a biorisk management program, which is one of many things that overlaps with other elements that funnel into an overall laboratory management program. So some strategies for integrating biosecurity into what you do currently. Understand your barriers and constraints. Are they administrative? Are they financial? What's preventing you from being able to tackle biosecurity in a little bit more comprehensive and concerted manner? You want to involve your institutional security. And I put this on here because same thing with the next bullet in terms of cross-pollinating your biosafety committees, your animal care and use committees, your institutional review boards, and other safety, security, regulatory type committees is, I think, part of being a good laboratory, whether you're an administrator, a manager, a tech, a student. I think a big component of that is also being able to know what your strengths and your weaknesses are. And this isn't always universally true, but if we're good risk assessment professionals and we need help from threat assessment professionals, let's go find them. And maybe that's somebody at institutional security. Maybe that's somebody in a third party that would be willing to come into your institution and help. Finally, engage the public. Reputational risk is a big thing. Perceived threats. I think we all know that perception can be much stronger than reality in a lot of cases. So understanding that, I think, can be very useful, but cautiously. I've been on IBCs where there were some questionable folks on there, like trying to plant a bomb. Anyway, what do you really need? What do you really need to build good biosecurity programs? You need the right willing people. You need a thorough knowledge of your assets. And I don't just mean, is it aerosol transmissible? If I get it in my eye, am I going to get sick? No, I mean the other assets, the other attributes of the agents you're trying to protect. Do they have monetary value? Are there dual use concerns? Understand those things. Understand what make them attractive to a threat or a hazard. I think you've got to have an honest awareness and appreciation of your institution's gaps and vulnerabilities. What are the threats? All these things are unique. They're institution specific. How do you prioritize them? That's really what that threat assessment process that we looked at tells you. Is there a strategic plan to work collaboratively to address them? Know when to get outside help. If you don't have the expertise in-house, spend the money, go out and get it. Maybe you find a volunteer. I don't care what it is, but if you don't have it, go get it. And of course, be honest, call it like it is. This is what you really need to, I think, start significant improvement on biosecurity programs. I would like to mention, though, we have wonderful biosafety professionals, and there are wonderful credentialing programs offered through ABSA International and ASM. ABSA is currently looking at, well, what about a biosecurity credential? This is an interesting discussion. I actually lead one of the subcommittees on this task force. Some of the questions that we're currently asking is, what would a credential look like? What are the criteria? What are the resources that say ABSA as a body, a credentialing body, what would they need? And is there even a market for it? So we're in process. You're going to be hearing about this in the coming months as you stay close to news coming out of ABSA. I'm curious to see where this goes, and I'm glad that I'm a part of this process to help work on this. I know some of the folks on the call are involved in this as well, and that's very cool. All right, we're going to wrap it up here. We're just at end. So after all of this, I say good luck. We're all counting on you. We're going to start with a poll question. Do you think your institution's biosecurity program is adequate? I realize not everybody's coming from an institution that has a biosecurity program, but let's open up the poll. It's anonymous, of course. Poll is open. A few more seconds. All right, I'm going to close it up. Share the results. About 10% of you think your program is adequate. 48%, just about half of you say, yeah, somewhat. 5% say no, 5% really don't know, and looks like about a third of you not really applicable. All right, next question. Do you or your institution's biosafety people participate in institutional security meetings or committee meetings? Let's open that one up. And if this is NA, don't worry about answering it. I forgot to put an NA category here. All right. Going to close it up and share. Over half of you say, yeah, that's cool. This is a very necessary thing, in my opinion, is that there's crosstalk between them. Obviously, institutions will vary, but this is a really big piece of low-hanging fruit, I think. All right. How about your security folks? Let's turn it around. Do they participate in your IBC or committee meetings? I'm going to launch that poll. second, going to close it up. Well over half of you say no, that they don't. This indicates for me, first of all, it just tells me something I already know. Biosafety people tend to be overachievers, right? They're going to go to the security meetings. That doesn't mean the security folks are going to come to their meetings. I get it. Anyway, again, I think you get the point. It's good cross-pollination. Finally, for future webinars, I want to remind everybody this is part of a recurring series that's going to be going on. And we would like to make sure that we're talking about some of the things that you guys want to hear about. So we'll do a quick poll here. You'll also have the opportunity to reply by email. I think you're going to get a post-webinar email out from GoToWebinar, where you can put in suggestions either about this webinar, what you liked, what you didn't like, as well as some things that maybe you would want to hear about in the future. So let me open this poll here, just kind of get a sense of where folks are. Poll is open. A few more seconds. Close it up. Interesting. The biggest hit is animal laboratory programs. Somebody out there speaking my language. I appreciate that. This may not be all the topics you want to hear about, but that's very, very good. It looks like I think people are starting to get a little saturated with the developing technologies, the defense programs. I don't know, still a little bit ambiguous from my perspective. Laboratory design is a big one. You know, I think about biosafety having a very big impact on how we design and operate labs today. What about biosecurity? That's a good question. Anyway, I know that you could really only select one here. You might be interested in hearing about more of these. That's fine. Please indicate that in your response email. We're not going to do a survey after this. I'm not going to have people fill out a survey. Just send me a note. If there's something you want us to know about this webinar, the future series, send us a note. We would appreciate hearing from you. So we are just about at time here. I want to say thanks to those that helped contribute some of the material, whether they knew they were doing so or not. Kavita with Griffin Scientific, Randy Murch at Virginia Tech, Sam Dietrich at APHL, Nick Dunaway with Inspirion Biosciences, ABSA, and even some of this material is I've developed working with the Association of European Threat Assessment Professionals and even ATAP, the American-based Association of Threat Assessment Professionals. Hope you guys will stay tuned for the next webinar session. I realize that we are slightly over time. Any questions that have been submitted that have not been answered, we will get those back to the group in writing. And of course, always feel free to reach out. If there are questions, comments, I'm always happy to chat. We don't have to wait for a webinar to do it. So I hope that was useful and entertaining, and you got something good out of this. Realize pretty high level. I'm happy to dig deep if our audience wants us to dig pretty deep. So again, thanks everybody. We will be sharing the slides. There's going to be a link that we will send out to everybody. That will be a link back on the Merrick website where I think you will have the opportunity to view or download this recording of the webinar. So again, thanks. Hope everybody has a great week and look forward to sharing some information with you next time.